Let's solve a interesting example, an interesting numerical based on PCM, that is pulse code modulation. So here, a speech signal has a total duration of 5 seconds. So for example, you have a speech, I am speaking, for example, for 5 seconds. Okay. So this is an analog signal. So you have a 5-second clip of an audio signal or a speech signal. And you want to sample it at the rate of 8 kilohertz. So this is your PCM, right? So it is a you sample it at the rate of 8 kilohertz. It means at the output of the sampler you will have 8 kilo samples per second, right? Or 8,000 samples per second. And then at the quantizer, what this question is saying, that we require SQNR of 40 dB. So at the quantizer, you set your number of quantization levels in such a way that the SQNR at the output of the quantizer is 40 dB. Okay? So now you have to tell that what is the minimum storage capacity needed to accommodate this signal. So this is your message signal. For 5 seconds you just have a clip, you sample it, quantize it and encode it. Okay. Encoding, for encoding, you will, if you are having L number of quantization levels, then the log to L and you take the integer, right? The greater integer of this, and then you encode it. So at the output you will have 8k samples per second and multiplied by log to L number of bits per sample. So you will have 8 log 2L, and I'm not saying this integer, you have to take the integer, okay, the nearest greater integer, right? So you will have 8 log 2L kilobits per second. And then since your speech signal has a duration of 5 seconds, 8 log 2L kilobits per second, you have to multiply it with the 5 seconds because your audio signal is of 5 seconds. So you will need a storage of 8 log 2L kilobits, 8 into 5. Okay, so you have to just 40 log 2L kilobits. So if you want to save it in a disk, in a compact disk CD, then you need a CD which has at least this much of capacity. So now our question boils down to just we want to know what is this value, right? This is nothing but number of bits which you want to represent per sample, right? So it is n, so we just call it n bits per sample. So just we need to evaluate this quantity. And in order to evaluate this quantity, we need to focus on this, that we require SQNR of 40 dB. So we know that from our theory classes that SQNR is 3L square by 2. So whenever there is it is not given that what is the maximum and minimum value of your signal and etc. So you can assume that it's a sinusoidal type of signal. Okay, because in the class I have we just derived this for the sinusoidal signals, right? So you can assume that. So it is a 3L square by 2. So SQNR is 3L square by 2. And SQNR which is given 40 dB. So since we remember that in linear scale this is your SQNR in dB scale, right? So it is equal to 40. So in linear scale, your SQNR is 10 to the power 4. So 3L square by 2 should be equal to 10 to the power 4 at least. I mean, we need SQNR of this. So if your SQNR is bigger than that, it's not a problem, but we at least need this much, right? So if you solve it, you will see that your L is 81.6. So there is one way to evaluate the nearest integer of log 2L. It's equal to this. Either you just first evaluate log 2L, it will come 6 point something. And then you can say the nearest integer, the nearest bigger integer is 7. But one more way is to solve, I mean, you can, because see, the number of levels are order of 2, right? 2, 4, 8. So number of levels at the quantizer will be either 2, 4, 8, 16, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. So you see that 64, this is lesser than 81.6, and 128 levels, which corresponds to the number of bits per sample as 7. So you have to, at the quantizer, you have to set number of levels as 128. Okay, because in order to get at least the SQNR of at least 40 dB, you have to use 7 bits per sample. So now your n is 7, or the nearest integer, greater integer to log 2L is 7. So now we can put this value as 7 kilobits. So how much storage is needed? 280 kilobits. Okay? Or you can convert it in kilobytes, or I mean, but at least this much of capacity is needed if you want to store audio signal which is of only this much duration. So if you increase the duration, of course you will need the capacity will be more. Okay.